in this session, in the next few minutes, I'm going to give you guys an introduction, a very high level overview about big data, right? So internally we have been talking about big data a lot lately, probably maybe for few months now, but this is like the first time that we are coming out with the concept and giving you all a taste of big data. I'm sure some of you are already aware of big data concepts, so I'm going to give you all a very high level conceptual idea about big data. So simply put, let's see what is big data. It's all about describing very large sets of data, right? So when you say very large sets, we are talking about terabytes, petabytes, hexabytes of data, right? Gigabytes don't count in that, right? So when we talk about large data sets, we are talking about both structured and non-structured data, right? So structured data are the ones that you are already familiar with, which goes inside your relational databases, which comes in tabular formats, right? So apart from that, there are so many unstructured data out there, right? Emails, documents, books, server logs, clickstream data, and you can go on. I mean, there are so many unstructured data which are not captured right now. So structured data are all data that can go inside a relational database model and which can be searched very easily, right? But the challenge with very large data sets, that means big data is, because of the huge size, it's very hard to store. You need so much storage, analytics is difficult, indexing is difficult. Like you have some challenges with dealing with big data. So back in 2001, Gartner came up with a 3 V's model to describe big data, right? So volume, velocity, and variety, right? Volume means you are dealing with so much of data, like terabytes, petabytes, and zettabytes of data, right? As I said, if you only have gigabytes of data, you don't have a big data problem actually. Right? Actually, in fact, one of the colleagues of mine asked me, okay, we only have like 150 gigabytes of data, and why are we bothered with big data? I will answer that question in the coming few slides. So we are looking at large volumes of data, right? Storage, the cost of storage has been declining since of late. So because of that allows us to store more data, right? And the velocity of data is increasing, right? The rate at which data that we have to acquire is very high, it's increasing. The variety of data, as I said, when you deal with unstructured data comes in different formats, right? Textual data, server logs, which cannot be translated into a tabular format, right? So these are the 3 elements, characteristics of big data, right? So since of late, we are talking about a 4th V. It's called veracity, right? So when you say big data, the data is usually bad data, right? The reason why we say bad data is they contain so much uncertainty. Some of the data are partial, some of the data are incomplete, some of the data are doubtful, right? So we need to do a lot of cleansing, right? So that's why we talk about veracity a lot these days, right? I'm sure you have come across big data use cases every day these days. If you look at Facebook sponsored links, it's all generated through big data infrastructure, right? Amazon recommendations. These are some of the recommendations that Amazon gives to me based on my past searches and past purchases, and that pretty much addresses my interests closely, right? So what's the challenge? Are you guys aware about the Moore's law, right? Back in the 1960s, this Intel's chairman came up with this Moore's law. He said every 2 years the processing power will double, right? But the data growth beats that, right? So you can imagine the challenge there, right? So right now the enterprises covers around like 20% of the data. We are able to capture only about 20% of the data. 80% of the data lies elsewhere in unstructured forms, right? So players like Google, Facebook, LinkedIn, Yahoo, and many other companies have been able to capture that unstructured data and make use of it and monetize it for their gain. So here's the traditional weave into data warehousing or business intelligence. What we do is we have a transactional database, then we ETL, that means extract, transform and load into a data warehouse, right? Then if necessary we ETL it into again. So that requires a lot of data being moved around, right? So when you have like terabytes or petabytes of data, moving data through systems is not a very effective way. It's not practical, right? And the turnaround time will increase day by day as you scale. And schema management. You have to have a schema with these databases, right? You have to prepare a schema for your transactional database. You have to have a schema for your data warehouse, a bit of an unnormalized sort of schema in your data warehouse, right? So schema management is somewhat difficult. So we are looking at a different approach for data systems, for managing big data systems, right? So we store data in raw format. We don't prepare a schema first. We load the data, then model, right? So we store all the both structured and unstructured data in raw format, right? Then based on your requirement, we create dimensions or weaves or sort of perspectives out of that data. So on top of that, you have your indexing, you perform your analytics, you generate your insights and generate your recommendations, do machine learning stuff, and you can do traditional CRUD, create, read, update, delete stuff, and all your applications consume that data from that data system, right? So if I elaborate a little bit about this raw data and weaves, well, here's an example. So OLO sales could be raw data, right? And you can have different weaves of that sales data. You can have trending menu items, influence scores, social media mentions, or whatever, right? So depending on your situation, you can create the weave or the perspective. If you go the RDBMS or the tabular path, you have to first create the schema for these things, then collect the data. So then you limit yourself, right? By the time your requirement comes, the data might not be sufficient. Probably we haven't captured the required data, right? So that's one of the benefits there, right?
This data is slightly structured in some way, right?
Right now it's structured, yes.
How do you create a view with an unstructured data?
Through a technology called mapreduce, which I will introduce, you can create ad hoc mappings. So let's see how we can implement this data system through the use of big data technologies. I will use Hadoop as an example, but note Hadoop is not the only solution out there, but Hadoop is very prevalent, and it's it's a sort of a major player in the open source big data sphere. So so I have used Hadoop as an example for the implementation. So let me explain a bit about the Hadoop ecosystem. Hadoop ecosystem consists of two main parts, this HDFS and mapreduce. Those are like the core elements there, right? So HDFS stands for the Hadoop distributed file system, which allows you to have a distributed file system across commodity servers. Commodity servers, just standard virtual machines that you can find in maybe Amazon, right? So for very cheap costs, right? So you can scale out, you can create large clusters, right? So on top of that distributed file system, you have something called mapreduce. That's the technology that does all the magic, right? So it allows us to do distributed processing across a very large cluster, right? Apart from that, you have other technologies called HBase. That's a column-oriented database, a NoSQL database, and there are other technologies like Hive. Pig scripting stands for it's a programming language. It's called Pig Latin, right? Remember, we are not using SQL to query from these databases. We can't, right? These are not SQL. That's why we call them as NoSQL, right? So if I give you a very brief idea about MapReduce, because MapReduce will require its own session, it's complex, right? But the fundamental thing that you should understand is MapReduce, two parts, map and reduce. Those are two functions, right? First you perform mapping, and then you reduce, means filtering, right? So as you can see, you can assume these as nodes, 3 nodes, right? 3 nodes containing 3 different data sets. So during mapping phase, you arrange it to different sets alike, right? Then during the function stage, you filter it out. So you do it in a distributed manner. You don't move data around the cluster, right? You perform the processing inside the node, right? That's the beauty of MapReduce, right? So yeah. So when you talk about big data, you will come across this word NoSQL, right? So NoSQL is everything is for everything other than tabular data, right? So the RDBMSs that we have does not scale for big data, right? That's why the industry came up with so many different NoSQL databases, right? So out there you will find many different NoSQL databases. These are some of the types of databases. Document stores. I'm sure all the Cinco guys know this CouchDB. That's a document store, right? That's a NoSQL database. Then there's MongoDB, another document store. And there are graph databases, key value stores. I think we use Memcache in our APIs, I think, right? There are object databases and column-oriented databases. These are different types. So how do you select these out of these technologies, right? So one of the fundamental theories that you should understand is this CAP theorem, right? How many of you have heard of this? I know you have. So you should know this this CAP theorem to pick a particular database which is suitable for you, right? So remember, these NoSQL databases are distributed, right? As soon as it becomes distributed, you cannot simultaneously provide all these 3 features. You can only get 2 features out of this at any given time, right? You either get consistency or availability, or you either get consistency or partition tolerance, or you either get availability or partition tolerance. Those are the 3 types of features that you can get out of this, right? So if you look at consistency, so let's say you have 2 nodes, right? So if there's consistency, you should be able to read and write from any node, right? Without worrying about the consistency. Right? Availability means, again, if you have two nodes, if one node goes down, you can continue serving data from that remaining node. That's availability. Partition tolerance means, if you have two nodes, the connectivity between the two nodes breaks, it gets partitioned, you can still continue to work, right? So CouchDB, in your opinion, in your view, to which category it belongs to? CA, AP or CP? Does CouchDB have consistency?
It's not eventual consistency.
Yes, it's called eventual consistency. It's not consistent, right? That means you get availability and partition tolerance, right? So likewise, you have to pick and choose these technologies. You have to evaluate the features of these databases, right?
What do you mean it doesn't have consistency?
You can pick only two, because if you need partition tolerance,
For CouchDB, why won't it have consistency?
sorry,
For CouchDB, why won't it have consistency?
because CouchDB supports partition tolerance. You cannot have partition tolerance with consistency, right?
So it's just like this, right? So you have your local CouchDB and you have your cloud CouchDB. If you save some data into local CouchDB, it doesn't mean it will be available immediately in cloud.
Yeah.
So there is no consistency between your local node and the cloud.
But it gets replicated.
It gets replicated. That's called eventual consistency. So eventually data gets consistent, but soon after you write, it's not consistent.
Exactly.
And I think most of the big data solutions are eventual consistency.
But
Yes,
databases
most.
will be eventually consistent in that case, right?
Some,
For like if you look at MySQL like model
yeah.
clustering, it is consistent. So until you write to all the nodes, that data is not available for read by the other clients. So that's where the consistency play a role.
Yeah, my databases like MySQL supports ACID, right?
Yeah.
These NoSQL databases does not support ACID, right? You don't get atomicity, you don't get transactions, right? So you have to understand the difference. So let's see how we can put big data to work, right? At Leapset, how we can utilize for our benefits, right? So before all that, let me put some context into it, right? What are some challenges the food services industry or the restaurants face? They have very thin profit margins, right? 3 to 5%. It's very labor intensive, right? Food prices are very volatile, and they have huge business risks. According to research by 2 universities, at the end of the first year, 27% of all the restaurant startups fail, right? At the end of the second year, 50% of the original startups fail, right? So all the risks that are in the industry will be our risks indirectly. Correct me if I'm wrong, right? So how we can solve some of these challenges with the use of data, right? So if we collect the right amount of data, we can make it one of our competitive advantages, right? We can differentiate in the market with providing very advanced analytics and operational insight, right? Actionable insight. I'm not just talking about showing graphs, giving them advices. Okay, this is what you should do to increase your productivity or increase your sales, things like that. We can do that, actually. We can do that with data. If we have the right amount of data and if we use the right models, mathematical models, we can do that. But unfortunately, this is the situation right now. Right? We are not retaining valuable data. Right? A lot of valuable data goes through our systems, but we don't capture that. Right? I can give you a few examples. For example, the OLO login. You can log in through the Facebook login. As soon as a customer logs in using your Facebook account, their Facebook account, you get access to their name, email address, their entire friend list. If you wish, you can get even more data out of that, right? So those are very valuable data.
We are pulling that out now.
Yes, we can pull that out. So that's one such example. And I'm sure that if you look carefully, you can find many different places that you can capture data. So with data, you can enrich your applications. Right? Take OLO for example. Right? You can make your search intelligent. Right? For example, let me if I'm searching for a restaurant from a particular location, then even through a browser you can identify the location. The browsers these days support that, right? You can detect the location. You can ask where the users are. Then based on that you can do give the results, right? And you can look back at the previous search criteria, then make suggestions based on that, right? You can give restaurant recommendations where your friends have been dining lately, right? You can show customers who dine at this particular restaurant preferred these restaurants or these menu items, things like that. And through data you can identify certain patterns, certain ordering patterns. So if you see a particular person ordering the same sandwich and the same coffee every day, so why not give them a one-click ordering possibility, right? Likewise, you can do food and beverage recommendations similarly. In the POS, inside the POS, with the right amount of data, you can identify the customer, those who are loyal customers. Then you can treat them better, right? Again, you can do food and beverage suggestions if you can identify the person, right? So as soon as you swipe the card, you know the person. Right? Fraud is prevalent in the restaurant industry, according to my research actually. So you can identify certain patterns, fraudulent patterns. You can give indications to the merchant, to the restaurant owner, right?
What sort of fraudulent
there was something called I forgot the name, cartwheel fraud or something like that. Likewise, there are certain very known
That means customers?
employees. Yeah. So you can do push notifications and email alerts. You can say, okay, to the merchant, to the store owner, you can say, okay, you are doing bad on your pizza sales. Right? Then the owner knows, okay, I need to take some action. There's something wrong happening, right? Things like that. Actionable insight. So now that we are in the table reservation space with bus table, so we can build table reservation intelligence, right? According to research, 20% of the table reservations gets cancelled, right? So for restaurants, table are their real estate, right? So you can deal with no-shows. You can through predictive analytics, you can tell the merchants, okay, these are the time periods where no-shows are very high, right? And you can even blacklist customers if you want, right? You can identify no-show customers, then tell the merchants not to take reservations in the future, something like that. And right now, merchants use these tactical overbooking as a tactic actually, right? So they overbook expecting no-shows, right? So if you can give them an indication of, okay, this is the amount of overbooking that you should do, then they can make more money. Right? So I mentioned about predictive analytics. Again, you can provide operational recommendations which are actionable, right? Basically explaining why and what to do, and not just showing graphs. You tell them why this is happening and this is what you should do in simple terms. And I'd like to introduce you to this concept called gamification. How many of you have heard of this word before? So gamification is simply introducing gaming-like activities to non-gaming contexts, right? Adding that playfulness to the application, right? Here's a good example. I think LinkedIn is one of the best sites that they use gamification effectively, right? So I recently posted a status update, right? So what LinkedIn is showing me, how many people have viewed that status update. Here it says 208 views and 4 people have liked it, and there's 1 comment. And with the circles you can see it's showing the first level of contacts, the amount of first level of contacts that have viewed, and the second level of contacts, right? So likewise it's showing me, okay, you have eyeballs here, right? So it's indirectly motivating me to buy the premium edition. There's the link, right? This one, right? Likewise, you are motivating the end user to buy more, to buy the premium edition, etc. So there are many other examples out there. Starbucks, with their My Starbucks rewards program, they use gamification. The Khan Academy, it's a learning education site. There you earn badges, right? The more you participate in the learning activities, the more badges that you collect. And Stack Overflow, there you earn reputation. When you participate, you earn reputation, right? I'm sure you have seen Stack Overflow. So these are some of the visualization. So big data, so it's all, we have to make it visual, right? There's enormous amounts of data. It's impossible to get insight from tabular formats, right? So visualization is very, very important. This is a visualization that my team members did. This shows where the Leapset merchants are, right? You can see the red dots where the Leapset merchants are operating, right? You can see some dots in the Florida area. These are mainly training mode or onboarding or testing mode, and you can see few testing machines here in Houston as well, right? These are some of the things that we can't simply derive just by looking at the data. Until we see this image, we didn't know that there were testing machines in Houston, right? Here's another view of the San Francisco area. You can see this is a heat map. You can see the density in the San Carlos area is high, right? This is something that it's very difficult for you to understand just by looking at the data, right? So in conclusion, so the future is for the data nerds or the scientists, right? So there are very good opportunities in the big data space, and there are good learning resources as well. if you are interested, there's Udacity. There are a lot of training programs on machine learning, data science, mapreduce, and you can learn mathematical modeling. There are a lot of resources out there. So thank you for participating. So I'll open the floor for questions.